Okay, so on the second half of the video, it's still just more rational inequalities. These first two are not so bad. These last two are going to take a little bit more work because you can see that they need a common denominator, thinking way back to algebra 2 here. So in number 5, we're going to find the x-intercepts from the numerator and the vertical asymptotes from the denominator, double checking that it does in fact have a 0 on the right side, which it does. So when we factor that numerator, okay, we're going to get, looks like x minus 1 and x minus 4. And factoring that denominator as GCF of x, and therefore x plus 2. All right, so that means our zeros are going to be x equals 1 and 4, and our vertical asymptotes will be x equals 0 and negative 2. All right, so we're going to draw a number line in order from least to greatest. So that's going to put negative 2 first, followed by 0, followed by 1, and then 4. Now, what that equals to, tells me my zeros are included, my x-intercepts. But no matter what symbol you have here, regardless, you need an open dot for your vertical asymptotes. They're always excluded values. All right, so you have a bunch of zones to test. Okay, and we are looking for that's less than 0, so negative. So if I choose a number that's less than negative 2, negative 3 would be a good option. I'm going to plug it in here. So I've got negative 3 minus 1, which is negative. Negative 3 minus 4, which is also negative. And that's divided by, now plugging in here is automatically going to get me my negative there. Then I have negative 3 plus 2, which is also negative. So even amounts of negatives, we're going to have a positive solution here. Now I need a number in between. So negative 1 would be good. So I've got negative 1 minus 1. Negative 1 minus 4. So negative still, both of those. And then here, plugging in a negative 1 to x will still make it negative. And then negative 1 plus 2, that one's going to be positive. So this outcome will be negative. All right, so we need a number between 0 and 1, so 0.5 would be a good 1/2. So 0.5 minus 1 is still going to be negative. 0.5 minus 4 will also be negative. 0.5 there, going to be positive. 0.5 plus 2 will also be positive. So we've got an even number of positives, or even number of negatives, so the outcome is going to be positive as well. Now I need a number in here, 2 or 3, whatever. You got unlimited options. So 2 minus 1 is positive. Sorry about the dog. 2 minus 4 is negative. 2 going in for that x will be positive. Then 2 plus 2 will also obviously be positive. So our outcome there is negative. I don't know why she's barking. Oh well. All right, one more. All right, greater than 4. She's not letting me do this, is she? Apparently she just had to go outside. Awesome. All right, so now I need a number that's greater than 4, so 5. 5 minus 1 is positive. 5 minus 4 is also positive. 5 going in there for that x will be positive. And then, of course, 5 plus 2 will be positive as well. So I got all positives. Okay, so it looks like my only 2 zones that work are in the middle. So here and there. So I have one interval, negative 2 to 0. And the other interval 1 to 4. Now the 1 to 4 gets brackets because of the x-intercepts, and they're included, and the negative 2 to 0. All right, so our numerator on this one's going to factor x minus, that's a lie. Yes, no, that's right, x minus 2, x plus 7. I don't know what I was thinking. In our denominator, x plus 8, x minus 5. So we don't have anything that cancels, which is fine. Our x-intercepts are numerator. So we're going to get x equals 2 and negative 7. Our vertical asymptotes will be denominator, x equals negative 8 and 5. All right, so let's get our number line. In order from least to greatest, it's going to be negative 8 first, negative 7, 2, and 5. Now all of these are going to be open dots. The vertical asymptotes are automatically open, but this is just a greater than symbol. There's no equals to, so the x-intercepts are also excluded. And since that is a greater than, we're looking for positive regions. So test the number less than negative 8. And we're just going to plug it in here. So negative 9 minus 2, negative. Negative 9 plus 7, negative. Negative 9 plus 8, also negative. And negative 9 minus 5 is negative. So 4 negatives, that makes a positive. Test a number in between. So negative 7.5. Negative 7.5 minus 2 will be negative. Negative 7.5 plus 7, that's just barely, but it'll stay negative. Negative, oops, see if I can get that to work. Negative 7.5 plus 8, that's going to be positive, but barely. And then negative 7.5 minus 5, that's negative. So you have an odd number of negatives, we're going to be negative there. In between, so 0 would be a good one there. 0 minus 2, negative. 0 plus 7, positive. 0 plus 8, positive. 0 minus 5, negative. So odd number of negatives, we're positive. Or even number of negatives. Jeez Louise, listen to me. All right, now here, in between 2 and 5, so 3. 3 minus 2, positive. 3 plus 7, also positive. 3 plus 8, we're still a positive. But 3 minus 5, that one's negative. I'll make sure I say this right. Odd number of negatives will stay negative. And then I need a number greater than 5, so 6. Six minus 2 is positive. 6 plus 7 is also positive. 6 plus 8, still positive. And 6 minus 5, also positive. All right, since I'm looking for the positive regions, I've got 3. I've got this one in the middle, and off to the end. So our first one, negative infinity to negative 8. Middle one, negative 7 to 2. And our last one, 5 to infinity. Okay, now let's talk about this for a minute. On 7 and 8, first thing it doesn't have a 0 on the right side. So all I have to do to get that 0 is to subtract 1. However, with rationals, we can't just have a random whole number thrown out there. The whole thing needs to be a rational, which means we need a common denominator. Okay, so luckily this one's 1. It's not too bad. So the common denominator of 2x minus 2 and 1 is going to be 2x minus 2. So if we think back to last year with Algebra 2, we write the new denominators and we figure out what to multiply by. Okay, so this one's 2x minus 2, and this one stays 2x minus 2. So it means we really multiplied by 1. So we multiply bottom by 1, we multiply the top by 1. So it means that first numerator is not going to change. But in our second fraction, we have 1, and then we have 2x minus 2, which meant I had to multiply by 2x minus 2. We multiply bottom, we multiply the top. All right, so this becomes minus, get my pen, 1 times 2x minus 2, which is 2x minus 2. Now be extremely careful with that numerator, because what it really is a distribution of a minus sign. All right, and this is all still greater than 0. Let's see, that's going to be negative x, and that's going to be negative 5, and over 2x minus 2. I have to get it down to one rational, basically. So numerator is going to give me my x-intercepts, just like always, which is going to be, let's see, negative 5, I think. Yeah, so add 5, divide by negative 1. Yeah, so negative 5. And then add 2, divide by 2, so 1 for the vertical asymptote. Again, draw your number line in order from least to greatest. We've got negative 5 and 1. There's no equals 2, so both get an open dot. Test a number less than negative 5, like negative 6. Remember, we're testing here. So I've got negative 6 minus 5. So this is really positive 6 minus 5, which is positive. And we're dividing that by 2 times negative 6 minus 2. So that's going to be negative. So the outcome there is negative. Now test a number in the middle, so like 0. So I've got negative 0 minus 5, which is negative. Then you have 2 times 0 minus 2, which is also negative. So that's going to be positive. And our last one, numbers that are greater than 1, like 2. So we got a negative 2 minus 5, that's negative. I got 2 times, that's a lie. What am I testing? 2. 2 times 2, geez, minus 2 is also positive. So I've got one region where I'm looking for positive solutions. And that is right here in the middle between negative 5 and positive 1 with parentheses. Then our last one, it's basically treating it the same way as we did number 7. Subtract that 8 over x minus 3. Get that 0 there on the right-hand side. Get your common denominator. So the common denominator of x minus 4 and x minus 3 is literally going to be multiplying them together. X minus 4, x minus 3. Because basically they don't share any common factors, and so there's nothing in common, so we multiply them by each other. Then we look into the multiplication step. So we went from x minus 4 to x minus 4, x minus 3. So we needed to multiply by x minus 3. So we multiply the bottom, we multiply the top. Same thing over here, we've got x minus 3, now I have x minus 4, x minus 3. So we're multiplying by x minus, x minus 4. You write it over the one denominator. I'm going to distribute that one, though. And the reason I didn't distribute on the second one is because I'm really distributing a negative 8. So I just wanted to make sure I cleared that sign. So that's negative 8x, positive 32. Combine your terms. We're going to get x plus 5 So now it's not so bad. And I already forgot what the sign was. Less than or equal to 0. Which means I'm looking for negative regions, including your x-intercepts. So my x-intercept there is going to be -5. My vertical asymptotes, x equals 3 and 4. So number line, -5, 3, 4. A number that's less than -5, so -6. We're plugging it in here. So -6 plus 5, negative. -6 minus 4, negative. And -6 minus 3 will still be negative. Oh, I forgot my dots. Okay, your x-intercept will be closed. Vertical asymptotes open. All right, sorry about that, I forgot it. Let's see, I need a number between -5 and 3. 0. 0 plus 5, positive. 0 minus 4, negative. 0 minus 3, negative. A number in between, so 3.5. 3.5 plus 5 is positive. 3.5 minus 4 will be negative. And 3.5 minus 3, that one's going to be positive. That's going to give me a negative outcome. And then my last one, greater than 4, so 5. 5 plus 5, positive. 5 minus 4, also positive. 5 minus 3, positive. So I'm looking for negative regions. I've got 2. There's this one and that one. So my solution will be negative infinity to -5 bracket, because that's a x-intercept, and +3 to 4 parentheses, because those are both vertical asymptotes.